stoichiometry problems. And with your stoichiometry problems, there are 4 basic types that we're going to look at. For those 4 basic types, we're going to kind of do them one at a time. I guess the ones in the middle are together. But today we're going to look at mole-to-mole problems where you're just using a mole ratio. You're going to have one part of the problem, you're going to go to the other part of the problem just using moles. Then on, the next day, Friday, I had to think about what day it was today, and we're going to look at mole and gram problems where you're going to start with moles and you want grams of your product, or you're going to be given grams of whatever you have in the beginning and you're going to go to just moles in the end. And then finally next week we're going to do gram to gram problems, and those are kind of the longest type of Stoich problems that you're going to see, where you're going to be given grams and you need grams of something else. So as we are looking through these different types of stoichiometry problems, I have a Holy Moly Mole map, which is in the back of your notes if you decided to print those or if you are following along with these. Or we made a foldable in class, and with this foldable, it does kind of help you go through that Holy Moly Mole map as well. Today we're going to focus in on down here where you are given moles in your question, and then you are going to want your answer in moles as well. In order to get from moles of your given compound to moles of whatever you need for your new compound, you're going to just use your mole ratio, which comes from your balanced reaction. We're going to add in molar mass, where we're going to use dimensional analysis in order to do that later on down the road. So as we look at our mole-to-mole problems, I'm going to switch over to my document camera. And when we switch over to my document camera, I'm going to show you how to do these mole-to-mole problems. With the problems, there we go. Your first step, because you do need a mole-to-mole ratio, is always balance your reaction. So I am given a reaction that is unbalanced in this one. So I'm going to have to balance it out. When you balance these out, you just have to make sure you have the same amount of both elements on both sides of the reaction. So my nitrogen here, I have 2, and I have 2 nitrogen. I have 4 hydrogen. I need 4 hydrogen over here. So if I put a 2 right there, that gives me 4 hydrogen and 4 hydrogen. My oxygen, I have 3, and over here I have 1, and then there's 2 right here, because that 2 times 1 is 3. So that's a balanced reaction. In terms of our mole ratios, we're going to think about these as ones and not blanks. And then I can look at the question. So when I look at the question here, it says, how many moles of water are produced if 3.65 moles of my ammonium nitrate are decomposed? So I have moles of this guy right here. I want to know how many moles of water I need in the end. So I'm only focusing in on ammonium nitrate and water on this one. I'm going to ignore the dinitrogen monoxide. Always, 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 always start with the number that's given in the question. We have 3.65 moles. And before, when we were doing mole conversions, we typically didn't write out the formula. You're going to want to do that now because I specifically have moles of ammonium nitrate. I have to get rid of moles of ammonium nitrate and go to moles of something else. So that helps you to keep track of what moles you have. So in order to get rid of moles of ammonium nitrate has to go in the bottom. Moles of whatever I need is going to go on top. So what I need is moles of water. The numbers that I use for that mole-to-mole ratio, remember, come from your balanced reaction. So in my balanced reaction, it says for every 1 mole of ammonium nitrate, I have 2 moles of water. So the way that you read this, you kind of can squeeze in the word mole right here. For every 1 mole of ammonium nitrate, I have 2 moles of water. So this one, I got rid of moles of ammonium nitrate. It left me with moles of water, which is what the question asked for right there. So now all I have to do is my work. I'm going to pick up my calculator, and when I pick up my calculator here, I multiply across the top multiply across the bottom, divide your two answers. So here I'm going to take 3.65 times 2. And when I take 3.65 times 2, my calculator says 7.3. Sig fig-wise, I have 3 sig figs right here. I need 3 sig figs in my answer, so I'm going to drop a 0 right there to give me my 3 sig figs, moles of water. So I have the work shown using dimensional analysis. I have my correct answer, my unit, and my sig figs for my answer. So that is the 4 points that your math problems are all worth. To look at another one, this one says determine how many moles of sodium chloride are produced when 4.25 moles of chlorine gas reacts with sodium. So I don't have a balanced reaction. So sodium chloride is produced. So I know that I'm going to have that. I have chlorine gas. Chlorine is in Brinkelhoff, so it gets a 2. Reacts with sodium. That's just Na. It's all by itself. It doesn't get any numbers because it is not in Brinkelhoff. I need to balance my reaction. So to balance this reaction, I have 2 chlorine. There's 2 chlorine. Gives me 2 sodium, 2 sodium. Now, in the blank here, that is a 1. It's implied. And remember, when we read this, it reads as for every 1 mole of chlorine, we're reacting with 2 moles of sodium, and you're going to make 2 moles of sodium chloride. Start with the number that's given in the question, 4.25 moles of chlorine. I want to know how many moles of sodium chloride. So there's my question mark right there for moles. To get rid of moles of chlorine has to go on the bottom. What I'm trying to go to goes on top. So moles of NaCl goes on top. As far as the numbers go, the numbers come from the balanced reaction. For every 1 mole of chlorine, I have 2 moles of sodium chloride. I got rid of moles of chlorine, left me with moles of sodium chloride, so I'm good to go there. So again, I'm going to get my calculator. 4.25 times 2 divided by 1, I can skip. Again, my calculator just has 2 sig figs. I actually need 3. So I'm going to put down my answers 8.50 moles of NaCl. This one says back to the demonstration. We wrote in the last video a balanced reaction for the demonstration with the copper and the silver 1 nitrate. Let me redo the equation real quick. Ooh, Ag plus Cu NO3 2. Have to balance this guy out with a 2 and a 2, and we had a 1 and a 1, and then that is very scribbly written, sorry. But that is what we had for our reaction. We're going to start with 0.2583 moles of copper. It wants to know how many moles of silver will form. So I'm starting with moles of copper. I'm going to moles of silver down here. To get rid of the moles of copper, mole of copper has to go on the bottom, which is 1, because there's a 1 right there. And then you have 2 moles of silver. This is not always a 1-to-2 ratio. I don't know why all those, I just made these up, and they just happen to look like that. So I'm going to plug this in my calculator. This has 4 sig figs, so I need 4 sig figs in my answer. So we're going to do 0.2583 times 2. So you get 0.5166 moles of silver. So again, we used dimensional analysis to show our work. Sig figs, unit, correct answer. We're good to go. I have one last one that we're going to do in this video. For the one last one, again, we have the demonstration. So I'm going to put the equation up there. Since it's already written, we may as well use it, right? This one says you have the same amount of copper. How many moles of copper to nitrate will be made? So in the question before, it says that we have 0.2583 moles of copper. We want to know how many moles of copper to nitrate will be made. So again, we're going to look at our balanced reaction. And this says for every 1 mole of copper, I have 1 mole of the CuNO3 2. So that's a 1-to-1 ratio. Pretty easy work, right? Because you're going to take this number times 1 divided by 1. It's the same answer. And that is okay. That happens sometimes. So we're going to produce 0.2583 moles of my CuNO3 2. So when we're doing these, you look at what is given for your number. Start here. The same unit has to go in the bottom to cancel. So this is moles of copper, so moles of copper. My mole ratio comes from my balanced reaction. These numbers come from the coefficients out front. If you guys have any questions, make sure that you ask. Again, my email address is mgable@crosbyisd.org. Have a good day.